The third study in this group of foundational knowledge is from Dr. Tim Wells at Cardiff University, and this is a renewal. So we provided funding to Dr. Wells and his group maybe 2 years ago, and they used that to look at the morphology or the shape and connections of neurons in the brains of a PWS mouse model. And that's important because it might provide insight into some of the cognitive difficulties that our children have. And they did some really beautiful work, which was presented at the conference, about how the neurons are shaped differently and how their connections are different than a typical brain. And so in year 2, Dr. Wells is going to look more closely at the electrical activity and functional circuits. So how does that alter how the neurons interact? And look at a detailed assessment of how that changes over development and determine the impact of those changes on cognitive flexibility. So we know our kids have a real problem with change and transition from one thing to another, and this could underlie that. So it's a project to really get a grasp on what the differences are so that we can start to think about how we might address those. So cognition is an understudied area in PWS. It's very important, obviously, to all of our families, but really the basis of cognitive deficits in PWS is very much unknown. So this will be a really important step to better understanding these problems. And if we better understand the problems, then we can begin to, look at different therapeutics and see how they would apply to PWS. So there are many genetic disorders now that are looking at therapeutics to improve cognition in other genetic disorders like Fragile X syndrome, Down syndrome, and we need to understand whether PWS, if the same drugs might be useful or not in PWS. So the long-term goal of this project is to address, a major deficit in our understanding. What is the basis of cognitive deficits in PWS, and first in the mouse model and ultimately in people with PWS.